Hello, Maikako Kumui here. Thanks for your time and attention. This is going to be the first part of 4 for Unit 6 review. Okay, Unit 6 is linear equations and their graphs. So, before we begin, let's start with a joke. Why did the boy eat his homework? Because his teacher told him it was a piece of cake. Yuck, 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 yuck. All right, here we go. We're gonna go through all these questions. I'm actually gonna create new example problems for you, so you still have all of these review problems to practice on your own. All right. So this should help you out a lot in completing this and refreshing your memory. The first thing I want to talk about is rate of change. Whenever you see rate of change, you will see this term when you continue math. It's one of the biggest concepts in calculus is rate of change. Rate of change is simply synonymous with slope. The letter we use to designate slope, to denote slope, is usually m. That comes from the French for monter, to climb, which kind of makes sense, right? We climb things that have slope. Lines come in a variety of flavors. You see lines kind of going pitched in this direction, maybe a little even flatter, but same, rising from left to right. We always must read left to right. Okay, sometimes lines are falling from left to right. Sometimes they're completely horizontal, as in this case, and sometimes they're completely vertical. So to remember some classifications of slope and rate of change. The first image, case 1, these are positive slopes, okay, things that are growing as x moves from left to right. In case 2, these are negative slope. How do we remember that? One way to remember that is draw a capital letter N. If you can draw a capital letter N using all of these lines, which you can, okay, capital letter N, that's a negative slope, meaning as x moves from left to right, as x increases, the y values are decreasing. The y values are decreasing. In case 3, horizontal lines, just like if you were thinking about your driveway, there is no slope. If this were your driveway and you're driving your car through here, there is no slope. Now we have to be very careful because slope is a number. Slope is a number that describes the pitch or incline, and we use the slope of 0 here. It has 0 slope, this driveway. It's nice and neat. But if you encounter, in case 4, if you encounter a driveway like this, if you're in your car and all of a sudden you're trying to get into your garage but you see a brick wall, it's hard to classify. It's hard to even say what the slope of that driveway is. It's not even a driveway. Keep in mind, the slope of a vertical line is undefined. Now, there are reasons for this. Just to review really quickly, if we're talking about slope, there is a formula. There's 2 ways we can calculate slope. It's a change in y, yes, y, over the change in x. It's also equivalent to rise, which makes sense because you're moving up and down in the y direction. Rise over run. Okay, so one common mistake is to think that slope is change in x over the change in y, but it is not. It is the change in y over the change in x. So let's take a look at this. In a horizontal case, if you do the change in y, you're taking -4 minus, I should write the formula actually. This is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. There is no second point and first point. You just need to go in the same order. All right, so that's how we calculate slope. So for this example, we would have the slope is -4, which is, let's start with this one, okay? Is -4 minus -4, because that's the y value of this point. And we have -5 minus a 3, okay? If we recall, subtracting a negative is like adding a positive, so we have -4 plus 4, that's 0, and this is -8. 0 divided by anything is 0, so that justifies that the slope of a horizontal line is 0. Furthermore, if you are moving from, another way we can think about that is if you're moving from this point to this point, there is no rise. So the rise, if you're thinking slope is rise over run, which it is, there is no rise between the 2 points, and there is a run of 8, or -8 if you're moving left, or 8 if you're moving right. In either case, the slope is 0. Now, if we apply the same formula for slope to this, Let's use this as our first values. We have 3 minus a negative 4, okay, because that's this y value minus this y value. And we need to go in the same order, so we do 5 minus 5. In this case, it didn't really matter, but we were doing this 5 minus this 5, same order. So we have 7 over 0, and one of the cardinal rules in math is that you can never divide by 0. This is undefined. There are numerous reasons why we can't divide by 0, but we don't want to get into it here, okay? There's very good compelling reasons. Just ask me and I'll explain. So that's a rundown of slope. We've got case 1, positive, case 2, negative, case 3, 0 slope, case 4, undefined, okay? Next, find the slope. Well, you know, actually, I hope I gave you some review on that already. But if you need it once more, let's do it real quickly. We've got points plotted, 2 comma negative 4 and negative 1 comma 2. We want to prove slope 2 different ways, okay? And I'll show you. One, we've already talked about the formula. So if this were the problem we were doing, it's a brand new problem, you could do 2 minus negative 4 over negative 1 minus 2. Make sure you go in the same order. This is going to be subtracting negatives like adding a positive, so we've got 6 over negative 3. We need to simplify that. It simplifies to negative 2. Look at the graph. This confirms that the slope is negative. Note, you can also go the other direction. You could do this minus this. Just got to maintain the right order. So you have negative 4 minus 2. That's the change in y. And the change in x is 2 minus negative 1. Notice what happens. This is negative 6 over positive 3, which amounts to negative 2. So have confidence you can go both ways. Notice you can also calculate slope graphically by doing rise over run. Let's say we're moving from this point to that point. The rise would be 1, 2, 3, 4, 5, 6. The rise is positive 6, and the run, which goes on the bottom, is 1, 2, 3. Negative 3 because we're moving left. The slope is negative 2. Now note, we could also be moving, who says we have to move up from point to point? Let's move down from this point to this point. So the rise would be, we always want to do rise first. It's rise over run. It's 1, 2, 3, 4, 5, 6. But negative 6 is the rise because we're going down. And a run of 1, 2, 3. Positive 3. Notice it doesn't matter how you do it. You're going to get a slope of negative 2 no matter what. And that's the beautiful consistency in math. Okay, so let's talk about how to graph. This is change each equation into slope-intercept form if necessary. Sometimes it ain't. Sometimes if it's in slope-intercept form already, we thank our lucky stars because it'll be nice and easy to graph from there. It's always a good practice to identify the slope and the y-intercept because you only need those 2 pieces of information to graph any single line in the universe. Lines are very simple. They have a slope and a y-intercept, and those are basically the 2 properties. Okay? So here's an example problem that I want us to do. Y equals 3x minus 2. Slope-intercept form, let's review. Y equals mx plus b. This is slope-intercept form. Okay? M is the slope. That is where the slope is coded, and b is the y-intercept. This is where the y-intercept is coded. Now, that makes sense. I'll explain that as I move on in this problem, but let's just look at this line and try to graph it. The slope, if you said the slope is 3, you are correct. We want to write that as a fraction, 3 over 1. The y-intercept is negative 2. So, knowing these 2 pieces of information, that's all you need. You're going to go down to the y-intercept. It's not the x-intercept, it's the y-intercept, and a slope of tree. Now, a slope of tree, remember, this is the rise, this is the run. If we go positive 3 rise, 1, 2, 3, and a run of 1, that puts us here. Notice you can also do a rise of negative 3 and a run of negative 1. Negative 3 divided by negative 1 is still positive 3. What would that mean? A rise of negative 3 is going down. 1, 2, 3. And a run of negative 1 is going to the left. 1. So that puts you here. Notice, again, the beautiful consistency of math. Okay? And that's your line there. Why it doesn't go directly through all of those, I think the graph is a little distorted, but you would get full credit for that. Let's come back to why, really briefly. Why is this the y-intercept? Sorry to be ironic, but it's because when x is 0, if you plug in a 0 there, you'd have 0 minus 2, and that happens to be the y value. Y value would be negative 2. Hence, that's the y-intercept. This is the y-intercept, not the x-intercept. Okay? Let's do one more problem. And yep, we're almost done with the graphing section. So let's do a problem like, have I included a problem? Yeah, okay, fine. Let's do another problem. Nice and snappy. We've got y equals negative half x minus 4. Do not be intimidated by all the negatives, and do not be intimidated by the fraction. Fractions are our friends. Why? Especially when it comes to slope. We have a slope of negative 1/2 and a y-intercept of negative 4. It's always good to identify these two pieces of information now. In thinking about the slope, when you have a negative 1/2, it's good to split the negative into one location. And it really only does need to go into one. Because if you look at this, negative 1 over 2, that's negative 1/2. And if you have a positive 1 divided by negative 2, that is still negative 1/2. This is going to come in handy in our understanding. So let's graph this puppy. We're going to go with a y-intercept of negative 4. 1, 2, 3, 4. And we need a slope of negative 1/2. Now, you can conceptualize slope as this slope of negative 1/2 as a rise of negative 1 that goes down and a run of positive 2. That's to the right. Bang. Or you can think about slope this way. Okay, you can resolve the slope as positive 1 rise, which is up, and left 2. 1, 2. Notice the beautiful consistency. These 3 points are indeed collinear. Okay. I think I could have did a, I'm going to see if I can move that. Nope, I'm going to redraw that. So it's going to go through here, here, and there. Much better. Okay, and you want your line to be longer, use your ID card or a ruler at home to graph it nicely. Sometimes we're not given a line in the form we want. The form we want for graphing is typically slope-intercept form. Slope-intercept form, y equals m, the slope, plus b, the intercept. Sometimes it's not, but that's okay. Let's roll with it. We know how to convert from, this is standard form, where x and y are on the same side, to slope-intercept form. So let's begin. Let's get the x's on the other side. Do we do it that away? Is this the problem I want to do? Let me adjust this problem a little. Let me go, let me change this problem a little. Let's go 2y plus 5x. Sorry, adjusting on the fly. 2y plus 5x equals 6. Okay? So you're going to get the x's on the other side. So we have 2y equals negative 5x plus 6. Okay, by subtracting 5x from both sides. Next, we divide by 2 to isolate the y. So we have y equals negative 5 halves x plus 3. Why 3? Because everything on the right side needs to be divided by 2. All we have to do now is graph that. The slope is negative 5 halves. Don't be intimidated. We want that. And we have a y-intercept of positive 3. Okay. Now, so when it comes time to graph, let's use orange. We go up 3, bang. And we need a slope of negative 5 halves. Again, you could think about this as negative 5 over 2 or 5 over negative 2. Either way, just make sure your line is sloped in a negative direction, negative orientation. Make sure you don't go that way. By going up 5, right 2, that would be a big mistake. Okay, so we go down 5. 1, 2, 3, 4, 5. And if we went down 5, we got to go to the right. Don't go to the left, because that makes a positive slope line. Or we go up 5. 1, 2, 3, 4, 5, and to the left 2. Okay, because it's positive 5 over negative 2. And there you go. That's how we graph this line. All right. Yep. so I did change the equation, but that is the correct graph for that equation. Alrighty, make sure you just get y by itself. Lastly, there's one more way to graph, and that's using x and y intercepts. So let me explain that. This is our example problem. What if we were trying to graph 3x plus 4y equals 12? Put your answer in coordinates. That's one important detail we want to think about. Then graph using the two intercepts. Okay. Here's a little doodle I love to make to myself to find x and y intercepts. I hope it helps you. I do it every time. This is an x-intercept. This is an x-intercept. This is an x-intercept. What makes the x-intercepts important is that they all share something in common. What do they have in common? Their y value, look at all those 3 points in circle. Their y value is 0. Bang. That's going to be key. Okay? Now let's look at these y-intercepts. That's a y-intercept. That's a y-intercept. That's a y-intercept. So what do y-intercepts have in common, and what's important about them? Well, it's the complete opposite. Their x value is 0. Okay, and that is our key. Just making this little doodle should help you a lot. So let's say we're trying to graph this. Well, to find the x-intercept, oops, that should be a hyphen. To find the x-intercept, looking at our doodle, looking at our key here, the y value is 0. And you solve for the x. Okay, so you simply plug a 0 in for the y. Okay, and you get 3x equals 12, and you get a y value, an x value of 4. Now to find the y-intercept, it's the complete opposite process. Okay, we know at y-intercepts, look at this green, that's another y-intercept, that's another y-intercept. The x value is 0, so you plug in x is 0, and you solve for the y, and you get a y value of 3. And then you simply graph these 2 points. We've got 1, 2, 3, 4, and 0, 3, and voila, that is your line. Okay. Now, we should always double check this just to be careful. And this is the beauty in math, the beautiful consistency. Let's put it in slope-intercept form. Why? Just for kicks and to double check our graph. If we divide it by 4, we would get y equals negative 3/4 plus 3. Is that this line? Well, yeah. Is the y-intercept 3? Yes, it is. Is this, oh, I missed an x, didn't I? Bang. Is our slope negative 3/4? Well, let's see. Is it negative, first of all? Yes, it is a negative. Because it's pitched this way, capital letter N. And we go down 3, that's the rise, 1, 2, 3, and a run of positive 4, 1, 2, 3, 4. So that is the line. That concludes the first part. Guys, thank you very much. Work hard. Mahalo. Ask me any questions. Aloha mai kako, kumui here. Thanks for the time and attention, guys. This is the second part on Unit 6 review, linear equations and their graphs. We're going to focus on writing linear equations in this video, but before we begin, I do want to share a joke. Why was the student's report card wet? It was below sea level. That's none of your tests, so you don't have to worry. Right? Okay, here we go. We're looking at focusing on writing equations of lines. All right, this is a huge skill and something we should be familiar with, but it contains numerous parts. There are numerous steps, so this can get a little more complex. Okay, this can be more challenging than simply graphing. There's a lot of moving parts here. So the first part is point-slope form. First of all, we've got to remember what point-slope form is. Point-slope form is the form of a line that looks like this. It is the best form of a line to use. I wouldn't say best, I would say the easiest. It is the easiest form to write the equation of line given a point and a slope. Hence, it's point-slope form. You might be wondering, what is that other form again? That's slope-intercept form. That is entirely different, but I will show you. Slope-intercept. Think about it when you write it. Slope-intercept. I will show you how to use this as well, okay? To write the equation of the line. So in point-slope form, let's review. Notice in black, Kumui's a little colorblind, so I'm not sure that's black, but the very dark parts of this equation, like here and there and there and there, the end parentheses, those are unchanging. That is the form of the equation. Okay, that cannot change. What can change? M, that's where you'll put in your slope. And what else can change? That x1 and that y1. That can change as well because that's the point. There are 3 pieces of information that goes into this, and it's the slope and the point. Be very careful. The x, notice it appears on the left in the point form, of course, x comes before y, but it's going to swing here, and the y is going to swing out there. Do not put the x first, attach it with the y, and put the y with the x. Okay, you've got to maintain the right order. So let's memorize this equation, and that's something to just be aware of. Okay, careful about the switch. That's my note right over. Oops. I was supposed to highlight that, not erase that. Careful of that switch. So let me show you guys. Let's practice writing the equational line with this as its slope through that point. Here we go. We have to first remember the form. Just for the sake of showing you, modeling, I will write the equation. I will write the structure of point slope formula. Okay, that is the point slope form. And I'm just going to start sliding things in. Y minus 6, because that's the y value. That's what I mean. Be careful. Get this value. Don't just have your eye go to the -4 and put in -4. Doesn't work that way. The slope is 2. And you have x because that you must have an x and a y. You still need x's and y's to have an equation of a line. If these were all numbers, you might just end up with something like this. Yeah, it's a true statement, but that ain't no equation of a line. It's just 3 equals 3. There's no way to graph that. Okay? So it's x minus, tricky. X minus a -4. You must write -4. You can't just write a 4 and say, oh, I already wrote the minus. No, the minus is in the formula. You need to bring the x value down, which is -4. Okay? And let's simplify this. Y minus 6 equals 2. We at least need to resolve these 2 signs, and that is our equation. Now, let's go a little further, just for consistency's sake. This problem is just asking for point slope form, so you can stop there. But it's my kulyana to show you the beauty of math and other ways to accomplish the same thing. So let's just put this in... we're going to put this in slope-intercept form. We're going to convert it. Let's distribute the 2. And let's add 6 to both sides. So you end up with 2x plus 14. Now, let's double check our work. The question on your mind should be this. Does this equation right here satisfy this information? Well, look. Look at your equation here. Does it have a slope of 2? Yep, it needed 2. Now, does it go through -4, 6? If you plug in a -4 for x, you would have y equals -8, because it's 2 times -4, plus 14, which is indeed positive 6. So yes, this is the only equation with a slope of 2 that goes through that point, and you nailed it. Okay, let me show you another way. This isn't called for in this question, but if you feel more comfortable using slope-intercept form to write the equation of line, then this is how it's done. I always love to start out with the mold, y equals mx plus b. I know I wrote it to the left, but I'm writing it again. Step 1 is to plug in the slope. I like to break it down step by step. Now, from here, I need you to realize that the only thing missing from here to make a full equation of a line is your b. If you get the b, you're all pow. So, what we need then to get b is a value for x and the y. We need everything to be numbers except the b. How do we do that? Oh, yeah. That's where this point comes in. Your y value is 6. Your x value is -4, and that allows you to solve for the b. You have 6 equals -8 plus b. You add 8 to both sides, and you get b equals 14. Now, what do you do with this b? It's very important. You take this b, and you don't go back up the top. Nope. You go right here. And so the equation of the line will be y equals 2x plus 14. Notice how beautifully consistent this is with that. Okay? So that's how you write the equation of a line given a point and a slope. Now this is a different challenge. Find the slope. How to write, this should be write the equation of a line, right? The equation of a line given 2 points. Aha. You're not given a point and a slope anymore, but you're given 2 points. But remember, you need 2 pieces of information to write the equation of a line. You always need 2 pieces of information. You need a slope and a point. Slope, m, and a point. That is what you need to strive for, because then you can use point-slope form. But if you're given 2 points, yes, we have to understand we're not given the slope. We have to find the slope. No problem. You guys know how to find slope. So let's just do this, these points minus these points, okay? Those values minus these values. So we got 2 minus -4. Remember, it doesn't matter. Just be consistent in your order. Minus a -1, okay? So this is going to be 6 over -2. We've got a slope of -3, okay? Put that information right here. Bang. Keep it on the side. Now at this point, you can use either one of these 2 points. I will prove to you that it shouldn't matter what point you use, okay? In this worksheet, it says use the first point. It doesn't matter to write it in point-slope form. I will show you that. So point-slope form, if you recall, look at the top, look over your notes, okay? It's up there, point-slope form. Pause the video if you need to. Y, I'm going to use the first point here, y minus 2. Remember, your I needs to travel to the y value. Equals -3 times x minus a -3, so I'm just going to cut straight to the chase and say x plus 3. Okay? And I'm done. I'm done. Let's simplify this, though, just to prove a point. -3x, minus 9. Then we're going to add 2 to both sides, so you have y equals -3x minus 7. This is the equation of line. How do you check that? This is the cool part. Plug in -3 for the x. That would be 9 minus 7. We get 2. We needed 2. Good. This equation that we wrote has to also satisfy this point. So plug in a -1. -3 times -1 is +3. 3 minus 7 is -4. That is the point we needed right there. Okay, you see that right there. Now that's using the first point, but could you have also used the second point, meaning this? Yes, of course. We got to understand, guys, there is no first and second point in real life. They're just 2 points in a graph in space, okay, on a 2-dimensional plane. So let's practice slope-intercept form again. We're going to have y minus a -4, so let's cut to the chase. It's y plus 4. That's the slope. And instead of writing x minus a -1, I'll write x plus 1. Okay? Now let's simplify this because it better be the same as that. Notice, this looks entirely different from that. So you might be wondering, can we use different points? Let's see. Y plus 4. Let's distribute -3x minus 3. Let's subtract 4 from both sides, and we got y equals -3x minus 7. Wonderful. It ends up being the same thing. Okay. So, yep, guys, please make a note of that. I have a little graph here. Is that because I wanted to show you how to graph this? Yeah, okay, sure. We got 2 points. -3, comma 2. We could find the equation of a line from a graph as well. Did we satisfy everything? We changed the equation to the slope-intercept form. And, we need to change the equation into standard form. Standard form, what does that entail? Guys, just make sure the x's and y's are on the same side of the equation. Okay, so let's move the -3x to the left. We do that by adding 3x to both sides. We have 3x plus y equals -7. This is standard form. Okay. All right, let's come back to this. How would we use a graph to help us? We've got -3, comma 2 and -1, comma 4. -1, comma -4. 1, 2, 3, 4. Now, how could we, if we graph, actually, I think the graph was just here to prove that we're in the right ballpark. Notice this equation, y equals -3x minus 7, matches this line. The y-intercept even in my very crude graph, clearly the y-intercept is about -7, and it does have a slope of -3. First of all, it's negative, it slopes that way, and you go 1, 2, 3 across 1. Across 1, 2, 3 across 1 puts you here, and 1, 2, 3 going up and across 1. Okay, there you go. All right, that concludes the second part of writing equations of lines. Again, that's might be a little shorter, but hey, there's this is pretty dense, so please review and study this really hard. Mahalo for your attention. Good luck. Ask me if you have any questions. Mahalo. Hello, Mike Ako Kumui here. We're going to build on the concepts from part 2 in this part. This is part 3 of linear equations and their graphs. We know how to write the equation lines, and we're going to just add some complexity by talking about parallel and perpendicularity. Okay, so before we begin, a quick joke. What did one pencil say to the other pencil? You're looking sharp. All right, here we go. Let's jump into this. So we know how to write equations of lines using not only point-slope form, but slope-intercept form. And we're going to take that to the next level. So they're asking us for point-slope form for the line that's parallel. The thing you have to understand with parallel is that the slopes are, well, let's talk about what parallel lines are first. These are parallel lines. Notice that their slope, their pitch, their slant is the same, and that is the key to understanding how to write the equations of these lines. So what if our problem was this? This is a brand new problem. How do we write the equation in point-slope form for a line that's parallel to this, but it has to go through this, okay? Because this point doesn't lie on this line. If we plugged in a 2 for x, we would get 1/2 of 2. 1/2 times 2, that's 1. 1 minus 4 is -3. This point is off of this line. It's not on this line, okay? So how do we write the equation of line that's parallel to this that goes through that? Well, remember, you need two things when writing the equation line. You need a slope. We know the slope. It's got to be half. We know, and then we need a point. We know the point. It's 2, 3. They're asking for point-slope form, so let's just keep practicing point-slope form. Y minus 3. Remember, your eyes got to search for here that y value. 1/2 x minus 2. Okay, let's expand this. Or convert it to point-slope form. 1/2 x minus 1. And then we're going to add 3 to both sides, so we have y equals 1/2 x plus 2. Okay, let me show you this should be consistent if we took this and wrote it in, tried to write the equation line using slope-intercept form. So slope-intercept form looks like this, you recall. Y equals mx plus b. That's our mold. First thing you do is throw in the slope. Then stop and realize all we need is a b. How are we going to get the b? Well, we got to put in all values for all the other variables. So y, it's 3. 1/2 times 2 plus b. 3 equals 1 plus b. Solve for b. b happens to be 2. Where does it go? Don't go all the way to the top line. Go right here, because that's the word you're missing. So the final equation is 1/2 x plus 2. Notice how beautifully consistent. Okay. Now, for perpendicularity, perpendicularity is a major story, okay? And for perpendicularity, do I want to talk about it here? Maybe I'll talk about it later, but to get into this idea, perpendicular, yeah, I think I do need a little picture for you guys. Negative 3x plus 1. Negative 3x plus 1 should look a little something like this. Y-intercept of 1, and it's got a slope of -3. So what does that entail? Make sure it's pitching this way. You go down 3. 1, 2, 3, and across 1. Bang. Okay. Or you go up 3. 1, 2, 3, and across 1. Okay. Now here's the key. To have a slope, this is the theory, to have a slope that's perpendicular, it needs to come across like that. It's got to create a 30-degree angle. I'm sorry, did I say 30? It's got to create a 90-degree angle. Okay, and notice, this line over here, this dotted blue line, that's pretty darn flat. Its slope should be close to 0 because the slope of a horizontal line is 0. So what is the slope of this dotted line in order for it to be perpendicular to the green line? Well, you simply see it probably goes through this point here and this point here. What is that? That's a rise of, first of all, it's a positive slope line. If this is negative, this has to be positive. They've got to be opposite signs, okay? If you're trying to draw perpendicular lines, one's positive, the other's got to be negative, okay? Or if one's negative, the other's got to be positive. That's always the case. So the slope of this blue line down here is positive, rise of 1, run of 3. Notice something? 1/3. There is a relationship between our target line, which we're trying to write the equation of, that's perpendicular to this, and the slope of this line. The slope of this line is -3. What's the relationship? These two slopes, in order to create perpendicular lines, need to be opposite, meaning positive, negative. If this is negative, this has to be positive. They need to be opposite reciprocals of one another. Okay? Sometimes you hear the term negative reciprocals. I don't think Mr. Mike uses that term, or Kumu Wen. I have seen books like that, though. I don't like that term. It should be opposite, meaning if one's negative, the other's positive. And when one's positive, the perpendicular slope line has to be negative. Okay, that's what we mean by opposite. A reciprocal, you just take the fraction and flip it. So, in order for it to be perpendicular to this, we need a slope of positive 1/3, and it needs to go through 5, 1. And we just apply our point slope formula. Y minus 1 equals 1/3 x minus 5. And since they don't want it in point slope form, they don't want it in slope-intercept form, you just leave it and call it a day. Okay, bing, bang, boom, and Bob's your uncle, your pal. Okay, this is really similar. Tell whether the lines are parallel, perpendicular, or neither. At least we have some groundwork. If I graph this first line, half x plus 3, 1, 2, 3, rise of 1. Rise of 1, run of 2. Okay, or I go down 1 and left 2. Either way, we've got a line that looks a little something like this. And if you graph this other line, you don't have to graph it, but I'm showing you. It's got a slope of -1/2. Ooh, cool. Look at that. Awesome relationship. They must be perpendicular. The one's positive, one's negative. Careful, careful. For it to be perpendicular, there are two conditions. It needs to be opposite reciprocals. Are these flips of each other reciprocals in terms of the fraction? No, they are not. And let me prove that to you graphically. Okay, to graph a line with a slope of -2, you can think of this as -1/2 or 1/-2 if you think that way. Either way, though, you've got to make sure your line decreases from left to right. So you go down 1. I'm looking at this first. Slope, rise of -1, run of 2. Or if you look at this, it's a rise of +1 and a run of -2. These lines are not perpendicular. Okay, they are not. No way that's a 90-degree angle. If you need to tilt your head and look at the screen, go for it. It's not perpendicular. So those are neither. If you look at this, this problem that I've created, these slopes are opposite reciprocals. And yep, I was talking about slopes of -3 and 1/3 up here, right up there. So we won't need to graph that. Actually, I saved myself some time. Those are clearly perpendicular. Okay. Next skill, changing an equation into standard form using integers. Standard form, remember, standard form is basically ax plus by equals c. A, B, C can be positive or negative. Kumu Wen, Kumu Mike, I know Kumu Mike likes to emphasize that he loves to have the A positive. That's just a preference, okay? Standard form, nowhere does it say in standard form that the A has to be positive. The A can be positive or negative. The B can be positive or negative. The C can be positive or negative. It just doesn't matter. Just make sure that the X's and Y's are on the same side of the equation. If we're putting it in standard form, though, we need integers. Oops. Integers are whole numbers and their opposites. Whole numbers, that's 0, 1, 2, 3. Whole, how do I remember that? That looks like a whole. And they're opposites, so we got -1, -2, -3, dot, dot, dot going this way and dot, dot, dot going that way. We need whole numbers and their opposites. So we start out, we got to get rid of that fraction, multiply everything by 2. So we got 2y plus 4 equals, this 2 will cancel with that 2. We do not need to distribute it because you only multiply by 2 once. You don't multiply this left side. I'm sorry, you don't multiply this right side by 2 twice. You just need to do it once. So x plus 4. Okay, you move the x to the left. So we can have negative x. That's totally fine. Plus 2y equals, you subtract 4 from both sides, and you actually get that. Write a 0. If it's 0, it's 0. Okay? That looks a little odd. You might want to double check that. How would we double check that? Well, let's just try to put this in slope-intercept form just for kicks. Remember, the original equation looked like this. 2x plus 4. Before we multiplied it by 2. So let's distribute. That's a half x plus 2. You subtract 2's from both sides. That goes bye-bye. That goes bye-bye. You have... Let's move the y over to the right, shall we? You subtract y from both sides. And you get 0 equals 1 half. 0 equals 1 half x minus y. Let's multiply everything by 2 just for kicks. Okay, I'm going to move over here. 0 times 2 is still 0. Then you have x minus 2y. Aha! This looks a little different from this, but no, they are equivalent. How do we know they're equivalent? Okay, if I wrote this underneath here, I would have x minus 2y equals 0. These two equations are equivalent because, okay, there's a couple ways we know this. Let's say we isolated y here. Okay, we'd have negative 2y equals negative x, and we would get y equals 1 half x. We already know this. Oh, no, we don't. We didn't do it. So if we were to isolate y here, we would get 2y equals positive x, and divide by 2, you would get y equals 1 half x. These are equivalent. You get y equals 1 half x either way. The other way you know that they're equivalent, guys, is if you just simply multiply this equation by negative 1 on the left and on the right. It doesn't do anything to the right because 0 times anything is 0. But if you multiply this left side by negative 1, you will get positive x minus 2y, which is what you see right there. Positive x minus 2y. Okay, they are equivalent. They come from the same equation. Okay, so that's how to convert to standard form. Hope that's a good review. And let's do a little word problem, and that's the end of this section. Let's say I have $200 in my account and I withdraw $30 a week. Write an equation relating the amount in the bank to the number of weeks. All right, so the amount in the bank, well, I have 200 to start with, and I'm constantly deduct 30 per week, where x is the number of weeks. It looks a little something like that. So this is a major skill in math of modeling, and this makes sense. If my x is 1, I'm going to have $170. If my x is 2, I take out two sets of 30, so I have 20 minus 60, 140. Okay? So good luck on that. If you have questions, guys, always let me know. Mahalo. Hello, Mike Ako Kumui here. Thanks for the time and attention, guys. This is the last part of your Unit 6 review, linear equations and graphs. We're going to primarily be talking about absolute value graphs. Okay, so we're going to start with a joke. Why should you take a pencil to bed? Pencil to bed? To draw the curtains. Yes, to draw the curtains. All right, ha ha ha. All right, let's get the math. Let's get to work here. All right, the Desmos is going to come in really handy here, and I encourage you to do this exploration yourself, okay? I'm going to graph something like that. Now, there's a couple ways we can do this, but absolute value, let's recall some things about absolute value. No matter what the input is in absolute value, the output will always be positive. Someone described this to me as like a fun house, okay? A fun house. If you plug in negative values into the fun house, which are absolute values, if you plug in a negative, if you go into a fun house with negative, you will come out feeling positive because you just went in the fun house. Same with absolute value. Even if you go in negative, you're coming out positive. You have a fun house, though. If you go in positive, you're still going to come out positive because it's a fun house. So if you take the absolute value of a positive, it's still positive. Okay, let me write that down. So the absolute value of a negative is positive, but the absolute value of a positive, for example, positive 5, is positive. Okay, it always outputs a positive. Now, here's the thing. Let me show you Desmos. Desmos is a great tool, and here's what I've set up. Y equals, if you look on the top left, I can't draw on this, so you're just going to have to follow my words as carefully as you can. Y equals absolute value of x plus a plus b. These are sliders. For a, this adjusts the value of a, and this adjusts the value of b. Okay? Now here's the thing. We're going to adjust the b first. This is outside the absolute value. And we're just going to play. We're going to adjust the b first, which is outside the absolute value. If b is positive, what happened to the graph? Did you see? This is if a and b are 0, so you just have the basic y equals absolute value of x, because a and b are 0. Pretend they're not there. Y equals absolute value of x. It's a perfect v, slope of 1, with its vertex at the origin. But if b is positive, it moves up. If b is positive, it moves up. Play around. If b is negative, it simply moves down. There's an explanation for this, and I'll get into it, but that's all you need to know. It moves down however many units the b is. So look at the graph. Its y-intercept is -7, and look at the b value. It is -7. Okay? The amount of units it goes up or down is equivalent to b. There's nothing funny going on there. Okay? You don't need to double it or half it or anything. If b is 1, it's simply 1 up. If b is 4, it's simply 4 units up. Okay, so that's what b does. That's the b is on the outside of the absolute value. Now, what does a do? Let's try. If it's positive, it goes up, and if b is negative, it goes down. That's intuitive. What if a is positive? We might think, oh, positive values are to the right. And if a is negative, we go to the left. Let's test that hypothesis. If a is positive, will it go right? If a is negative, will it go left? Let's see. If a is positive, will it go to the right? Where is the v shifting? It shifted to the left. There is a reason for that. I will go into it. But just know, if this equation is y equals absolute value of x plus 2, it is opposite. If the numbers are inside the absolute value, the effect is opposite. It goes to the left. Now, if this equation happens to be y equals absolute value of x minus 4 plus a -4, that's minus 4. Y equals absolute value of x minus 4. Look at the graph. It's gone to the right. Anything inside is going to be opposite. Okay? I encourage you to go to desmos.com. Desmos.com. I will spell it out for you. Oh, wait, I don't want to do that. Desmos.com. And play around. Set it up just like I did. Desmos.com. Or graph all of these to convince yourself that this is how absolute value works. Okay? So let's graph this. Y equals absolute value of x plus 2. If you've learned the lesson from that, if it's plus 2 on the outside, it simply goes 2 units to the up direction. 2 units up. 1, 2. And we're looking at this V pattern. And we're looking at this V pattern. Okay. Bang. Okay, and draw arrows indicating it goes on forever. How do we double check that? Well, let's practice. If x is 0, y is 2. Okay, if you plug in a 0, the y is 2. That is why it moves it 2 units up, and that corresponds to that point, the vertex. If we put in a 1, y is 3. If we also put in a -1, because the absolute value of -1 is 1, we get a y value of 3. This is why the V pattern arises. If you put in a 1, 3, that's 1, 3, that's here. You put in -1, 3, that would be here. If you plug in a 2, you get a 4. Yep, we see that here. 2, 1, 2, 3, 4. And if you plug in -2, you're still going to get 4, because the absolute value of -2, the absolute value of -2 is 2. 2 plus 2 is 4. Okay, and that point would be over here. That moves it 2 units up. So we should know how to graph this, and we should know how to graph that. Check Desmos if you are unsure. Now, left and right are a slightly different story, so let's practice on this. Y equals absolute value of x plus 2. I told you there's an explanation. We know this is moving left and right because it is inside, the adjustment is inside the absolute value. So if you're ever unsure whether it's gone left or right, you just simply plug in some points. 2, 3, 4, 5, 1, 2, 3. 1, 2, 3, 4, 5. All right, it's 5, -5. 5, -5. All right, so plug in some points. The easiest point is going to be, let's go with 0. 0, if you plug in a 0 for x, you'll get a y value of 2. That's not really what we want, though. What we really want is to see where we plug in a -1, we will get -1. All right, that's -1. -1 plus 2, that's +1. Absolute value of +1 is 1. And here's the key. When x is -2, the y value is 0. You need x to be -2 in order to have a y value of 0. Okay? Focus in on what I just said. You need x to be a -2 to have a y value of 0. If you plug in a -3, we've got -3 plus 2, that's -1. Absolute value of that is 1. And we're starting to see the symmetry arise. -4. That's going to be -4 plus 2. That's -2. Absolute value of that is 2. Absolute value of -2 is 2. So let's graph all these. Well, here's 0, 2. Here's -1, 1. Here's -2, 0. Bang. That is the vertex, okay, of the absolute value. If I can go -3, 1 and -4, 2. That is why when you have a plus on the inside of the absolute value, it shifts it left. Why? Because the x needs to be a negative to zero out the y value, to have a y value of 0. The x needs to be negative to have a y value of 0. Or you just memorize its opposite. This is just left 2. Let me graph you another one. If you have x -3, you might think, oh, that moves it 3 units to the left. No, it does not. It's opposite when it's inside. This will guarantee move it 3 units to the right. How can I prove that to you quite quickly? Okay, this is right there. I can prove that to you quite quickly. Why? The x value, you see that x value? It needs to be 3. When the x value is 3, when the x value is 3, the y value is 0. And that's how we know it's moved 3 units to the right. To the right. It is the opposite of this guy. Oh, a little too big. It's the opposite of this guy. Okay, 3 units. That's -3, so we need to go 3 units to the right. Okay. Guys, the quizzes, you're on your own. Those are worth points. This review is worth points. So good luck. Try your very best. Ask me any questions you have and rewatch the video as many times as you need. Okay, mahalo.